Here we go. So the net force that acts on the particle will be equal to zero. So here's the thing. You have a velocity, right? And can you guess how, the way the acceleration works is a change of that. So if it's moving around the circle, you're having a change of velocity over here. So this A is wrong. Now this one is actually obviously the right answer. Um, I think the other one is like bad, but basically you can't change mv. I mean, you can't change mv if it's constant. You can't. You just literally can't. That's literally it. Well, energy you can because it's mv squared. So this square can be, hey, it is +5 right now. Oh wait, it changed to -5 right later. Well, this works. That's valid. No, that's a valid change. Therefore, it's not. The net force acting on the particle will equal. Oh yeah, so the force acted on the particle, and then it's not zero. There's a huge entire jump or whatever. Um, yeah. Although this is impractical, more like a circle like this will happen. But anyways, because it's a scalar, it can move around. Anyways, and then constant has the same reasoning as this one. Like, it doesn't mean squat. So, with that said, we're done with that one. Let me delete this. It's not letting me delete. So over here, 1 Newton is the force required to what? Give 1 gram mass an acceleration of one what? What's that even mean? Um, so this question is probably just testing something weird, but so Newton is ma, okay, equals something, and this is equal 1 Newton. So if, for example, let's go for B. B is 10 grams multiplied by 0.1 equal 1. So this is valid. So this must be it. But yeah, this one has a little unit change over here. It's really tricky there. And then there, yeah, this one is B. Okay. 550 kilograms mass initially at rest is acting upon by a force 50 e what the hell? No way. What is the acceleration speed and displacement of the mass at t equal 4? Okay, so that's interesting. So all you have to do is say mf equal ma, and we know that equals 50 et, and know that it's 550. So a, we already got a's equation. This is the equation for a et. Now, look at that. It's all the same. Whoever designed this question clearly knew that was the easiest one. Okay, v is the integral of that, right? A dt. I'm assuming there's no initial condition, which means the velocity is at rest. Yeah, it is. So it's 50, 500 et. Again, wait, that just means that. Wait, did I do something wrong here? I think the plus c must matter then because none of the things actually done it. I was gonna skip that because I thought it didn't matter. I guess it does if you look at it this way, because if it's zero, it's 50 divided by 500 plus c equal zero, right? So c must equal -50, 500, I guess. Oh, that makes sense. Sorry, not 500, 50, like that. So what that means, if I multiply this by 4 on my calculator, I should get something. All right, I get 50 by 550, and I get e to the 4 minus divide by 50 by 550, which is about 4.87. So we can already delete these two now. And now we integrate again to get x equal integral of v dt, which equals 50 by 550 et plus apparently minus 50 divided by 550 t plus c2. And this is at rest at 0, 2, right? Yeah. Et minus 50, 550. Oh my God, I keep making that mistake. T plus C1 equals 0. So this is 0. Wait a second. If that's 0 and that's 0, is it C1 again? Just C2, sorry. The same as -50 divided by 550 as last time? Damn. They didn't get creative at all. So multiply by 4 minus division 50 divided by 550. It's about 4.50. 4.508. So it's A. So it's A. I'm not going to question it. I'm just going to take the free A and move on, right? No way. Anyways, so calm down. Problem 4 and 5 refer to the following situation. A 5 kilogram block begins with address and slides down the incline. After 4 seconds, the block has a velocity. All right. Problem 4 and 5 refers to the following situation. A 5 kilogram block begins from rest and slides down an inclined plane. Um, inclined plane. After 4 seconds, the block has a velocity of basically 6 meters per second. If the incline, okay, so that's basically all it gives. Like 5 kg begins at rest and slides down. Incline, okay. If the incline is 45, how far has the block traveled in 4 seconds? Okay, cool. And is this frictionless or something? It must be because it's not giving me any information about it. So yeah, I will assume it's frictionless. And then that would mean gravity is the only thing that matters here, right? Unless gravity doesn't matter here, which interesting. Did they say gravity matters or not matters? Okay. No, it didn't. So that's an interesting one. Um, okay, I think we're gonna have to figure out the initial acceleration, right? Because that's the only way we're gonna get somewhere. Assuming that I don't think it says mm, it slides down incline, right? And after 4 seconds, the block has a velocity 6. So let's think for a second. It must have a constant because it's going down. So I'm going to assume something. V final equal V initial plus AT. So V final, we already know is 6, okay? And then V initial is 0. So plus A. A is something we don't know. So it's divided by T. T we know is 4 seconds. So 6 divided by 4 equals acceleration. So I think that includes all the gravity and other stuff. That's why they include it. You need to figure out yourself, I guess. About 1.5. So 1.5 is the meters per second because of friction and everything. Anyways, how far does it travel after 5 seconds? I think it is clearly just saying S equal SO, which is 0, plus VO, so that's 0, plus 1/2 1.5 t squared. And this is what we're trying to figure out. So 1.5 divided by 2 multiplied by whatever is t, which is t squared, which is about 12. So it's D, I think. So next up is this one. What's the coefficient of friction between the plane? Okay. Over here we find what's the coefficient of the friction in between. And over here, what we do is basically get the blocks over here. Do this, do this. We get 45 degrees from earlier. And then we just solve this. So we have to get summation of fx equal max, which basically right now is mg. And it's going to be, if this is data, right? This is xy. So this is sine 45. It's going to be negative. It's going to be plus, it's moving downwards, right? Sliding downwards, FFR, which we can just eradicate and just say mu n, positive and negative. Okay? And with that said, we can do the same thing with Fy, because this is called MAY, but that actually still equals 0. And that must be mg cosine 45, right? Because this is the 45 over here. There's no other force I can think of that could create a normal force. So it must be plus n, and it's negative, so it's n equal, this equals 0 still. So mg cosine 45 over here. So this equals max still. So now we erase this part over here and put mg cosine 45, get rid of this term. So ax equal g sine 45 plus mu g cosine 45, even though we know 45, cosine 45, sine 45, the same thing. What is mu is the question. Do we know ax? It slides down with 2 per seconds. I think we found the acceleration last time, right? No, we didn't. Okay, so after 4 seconds, the block has a velocity of 6. All right. Um, we're gonna have to figure it out, aren't we? Unless we did figure it out earlier, and I just forgot about it. Oh, I think we did actually. I think it was 1.5, wasn't it? Yeah, 1.5. I think it was. 1.5 equal, so 1.5 was it, right? And 1.5 was using the AT equation. So basically it was last time we did it. I think last question had it. V final equal VO plus AT. So A must equal VF divided by T. And we know VF is basically V is um, 6 divided by 4 seconds, which is 3 divided by 2, which is 1.5. And with that 1.5, we can do minus mg cosine 45 divided by, oh wait, not the mg, the g is gone. G cosine, no, this is sine, sorry. And then this is cosine 45. Basically, is what's happening, equals mu. And there's a negative, yeah. I'm pretty sure that's what you're supposed to do. And then it's 1.5 minus 9.8 cosine 45. Okay, parentheses. And it's 9.8 cosine 45, sine 45 on the top. Okay, I get negative 0.4835. I guess that's C. I'm sure I made a mistake in the notational like direction, which probably is over here. This is negative probably. Um, oh no, this is positive. I guess this is negative, and this is negative over here. I just yeah, forgot the negative sign. Oh well, it's not really a big deal. Yeah, it just changes one sign. Oh well, you get C anyway. Over here, we go to this question over here, 6. So a constant force of 750 newtons is applied to a pulley system to lift mass 50 as shown. Neglect the mass and friction of the pulley. What is the acceleration of the 50 kilograms? Oh, okay. This over here is 750, right? Tension, so 750 over here, right? And that would mean there's a lift force over here. Wait, I'm pretty sure there's another way to do it with the length analogy, but well, we're already doing this. So 50 multiplied by 9.8 is what? I don't know. Get the calculator out. Well, we can just show you what I'm thinking of. Over here is 750 times 2, right? So it's 752, and then we're gonna do minus there's 50.9.8. So 750 multiplied by 2 minus 50 multiplied by 9.8. We can just do it this way. So 750 multiplied by 2 minus 50 multiplied by 9.8. And then that equals max in the a direction. So you have to divide by m, which is 50. All right. Okay, I get D. I think that's the answer. Divided by, I'm just double checking. Okay, I got D. Hope that's the right answer and just move on, I guess. Um, and this is all right. We're just gonna assume that's correct and move on, I guess. Um, with that said, I think that's the last the normal question. Actually, is it? No, 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 no. There's much more than that. Okay, we are gonna do that question now. All right, all right. A mass of 10 kilograms is suspended in a vertical spring with K equal 10. What is the period of the vibration? Well, the square root of divided by m equals basically equals time over here and 2 pi over here. So you don't even have to think. 10 divided by 10 is 1. And then 1 squared was 1. So divided by 2 pi. No. T equal 2 pi, which is about 6, which is D. I guess that's a question. That's a nothing burger, but that's a question nonetheless. If you don't know, it's 3.14 multiplied by 2 I did, and then I did internally, which is basically this. And I was like, oh yeah, that makes sense. Yeah, that's what I did. And if you want to double check, go to your calculator and do 2 multiplied by pi. It should give you 6.228 something. Anyways, we move on. Next. If the sum of the force is not equal to 0, the particle is. Did we do this question before? I swear we did this question earlier. Didn't we? Didn't we? I don't know. The moving with the constant velocity in a direction is the resultant force. If the sum of the force on the particle is not equal to 0, the particle is moving with the constant velocity in the direction of the resultant force. So if not equal to 0, so it's not equal to 0. Not quite. You can be having a velocity initially and doing it like this, so no. A is wrong. Acceleration in the direction opposite to the resultant force. No. No ways. Acceleration in the same direction as a resultant force? Yes, acceleration is that. Yes, acceleration. Moving with a constant velocity opposite direction. What are you even saying? I don't even know what you're saying. C, because ma is equal to f, and this is the only vector, so this vector and this vector must be consistent. If they're not, they're fucked. All right. Varying force act on a 40-kilogram mass as shown in the following force versus time. What is the object velocity at t equal 4 if the object started from rest? And this is acceleration, I'm assuming. So here's the thing. What is the object velocity at t equal 4? Wait, isn't that 0? Wait. Before I say that, let's look at this thing. So it is the function of f from 0 to 2 equals what is this? 3 divided by 2 x. T, that is the function of 3 divided by 2t equal ma, right? So acceleration would have equal 3 divided by 2 t divided by m equal a, right? Right. And you would integral that to figure it out. I think, wait, am I being dumb here? I might be being dumb here. I think I am being dumb. So I think this is something like the impulse or moment question. I guess we can do d p equals dt equal force, right? So instead of doing this, we can take an integral of this, and we take an integral of this, and dt. So integral of this, we can do it like that. But I think you could just do delta, right? Because if this acceleration is whatever, doesn't that mean it's just an area? No. So let me just do something quick. I mean, it's F delta t, right? Equal m delta v is what we usually do. And usually in these questions, we can do this because it's usually just a constant acceleration or something. But maybe we can do the same thing over here. Well, it's impulse, right? So instead of doing that, we can get the area under the curve is what I'm thinking of. But none of these actually give you the area. Let me check the original question over here. No, it is correct. It is what we're looking for. All right, let's try it. Because you're supposed to get the area under the curve right here, and that's supposed to give you some stuff. Um, yeah, okay. So here, and then divided by m is what I'm trying to say. Um, So 4 multiplied by 3 equal 12, and then divided by 2 is 6. Divided by, oh, yeah, yeah, I was thinking it didn't make any sense because it was too big, but I forgot it's divided by mass, so it's 6 divided by 40. And then that is about 0.15, which is C. Okay, it makes sense now. Okay. I forgot about the mass. I was like, that doesn't make sense. It'll give you like something like 100, like a number like a whole number, and I was like, no, that doesn't, no. Anyways, that makes sense. We're doing this question over here. The way we'll do it is first we'll get the summation of fx, which is max. With that said, that would be the weight on the x direction minus mu n equal max, right? Right. So this over here is mg cosine theta, and then we're doing minus mu mg sine of theta equal max. What does this give me? Well, this gives me the whole thing. You just have to solve for it now, which over here is a 12, 5, 13 triangle. So we can do, what's it, 12 over 13, and then we can do 52 multiplied by 9.8 over here, minus 0.15. Same thing over here with, actually, can't I just get rid of the m? Yeah, I can. So with that said, let me get my calculator out and just do it. So we have 9.8 cosine of, we don't need to do cosine, 9.8 multiplied by division. We have cosine, which is a 12 divided by 13, minus 0.15 multiplied by 9.8. Sine is 5 divided by, so multiplied by 5 divided by 13 equals about 8. I got 8. Did I do something? No, that's about right. Okay, did I mess up somewhere? 5, 13. I think, yeah, that's 5 over 13. Oh, wait, cool. I think this is wrong. Um, I think this is sine, and this is supposed to be cosine. Sorry. Because this n over here is n. So if you look over here, basically, it's obviously this angle over here, which is this angle. So this is the cosine is that, which I don't know why I didn't think of that. So I flip all those signs out, so it's 12. And then the other one is definitely 5, which gives you 2.8x equal 2.412. And then with that said, what we can do is now we need to figure out the velocity at position B. We can figure out we can do a lot of math, but we can also do this equation over here because we already know this and that. So that equation is called V final squared equal V initial squared, which initial squared is 0. And then we're going to do plus 2a0 by s minus s, so which is going to be 20. So that means we can do VF equals square root of 2AO multiplied by 20, I believe. 2 multiplied by 2.412 multiplied by 20 equals about, I guess, 9.822. Here's the thing, that is V. So we got it, 9.822, so that's about a D. All right. So yeah, it is the P force, I'm pretty sure gets played later because there's no way that the P force is active now. That 383 probably is later. This is basically doing equilibrium, like getting all the sums added together. All right, last time we found that it was 9.83. So over here we're gonna do it. So over here we have B at 9.38, right? And that's a velocity. That's not an acceleration, therefore it's not a force. So notice that all the forces are gonna be in the form of a constant acceleration. That is because there's gravity, friction, and things, blah, 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 blah. All of them are going to be constant in the end. Okay? So we're decelerating here. The question is how much. So Let's begin here. Understand, the friction, you usually think it's a movement, but when it's actually moving, it turns to a friction kinetic, which is a constant. Okay, when it's moving. That's the friction force, sorry. Yeah, that's not supposed to be F CK, but whatever. We have a summation of Fy equal Maxay, right? The summation of Mx equal, oh, sorry, sorry, my mistake, Ax. This thing, we need both of them. But for now, let's stick with Fy equal May. No, no, sorry, Mx. The reason why is because we will be using the y direction for normal. And the biggest mistake that everyone makes. What is a normal force? It's not just gravity. It has another force. It's a p force. Over here, the p. Eh. So you have to take account the normal force over here and the p force over here when at B. So this is the position between B and C, the length. So clearly we need all that. Okay? So first, with gravity, there's this force, which is mg sine theta, negative direction if we choose this as positive and this is positive. I think last time we chose the other way, but this doesn't matter. Anyways, summation of f, right, y equal may. Okay, we're good. So, next, what's up? We need to think about the plus p force. What do you think it will be? Well, let's look at this. Y direction. This is like this. This is the angle over here. Same angle over here, it looks like. Okay, that would mean it is, I believe, a cosine. So next, we have to add the mu normal. Now, mu normal is the opposite of the movement of the block. Of the block. Or a box, whatever you call it, whatever you want to call it. Actually, it's your choice. Now, if it's opposite of the block, first of all, you're supposed to actually say plus or minus before you actually look at the direction. But we know the movement is descending. So we could do plus mu n because the friction is always opposite of the motion, the velocity motion. And I have it in my textbook a long time ago, y. And this equals MAYX. This should be X. This should be X. I don't know why people are making mistakes here. Probably because I had to restart this video like 3 times already. Mu M F X equal MAX. MAX equal this. Now summation of MY equal 0 actually. Because there's no movement in the y direction. By the way, this is a y, this is x with the coordinate transformation over here. Classic coordinate transformation. You don't have to explain yourself. If you do explain yourself, you're actually kind of weird for doing that because this is a simple coordinate change that you learn in high school. I don't think I need to explain that, right? Yeah, okay. So mg over here, cosine theta, and it's negative, right? There's also a p force, and it's going downwards. So minus p sine theta, and then there's a normal force. So that's a plus n equals 0, and therefore equals mg cosine theta minus p sine theta. You can guess which one that people make mistakes on. I'll give you a hint. It's this part. The reason they keep on making this mistake, this is the one that you need to look out for because people forget this, is because we're trained in high school to always look as the normal is the gravitational cosine thing. But we always forget the real definition of a normal is all the opposite forces that react in a perpendicular way, normal to the surface of the plane. That's solid. So that means this is true. Don't forget it. That's the hardest part about this question. So you can see that the full equation now in the y direction is mg cosine theta minus p sine theta equal max. Okay. With that said, we move this over here. Negative mg sine is 5 divided by 12 or 13 plus p 12 divided by 13 plus mu parentheses m g. What is this cosine? It's 12 divided by 13 minus p, and it is, what is it? Sine. So 5 divided by 13 looks like equal max. Okay. We can divide by m, and we can get ax. Ax equal negative g 5 divided by 13 plus p over m 12 over 13 plus mu g over 12 over 13 minus p over m 5 over 13 There we go. Let me do this in my calculator real quick, and hopefully I didn't make a mistake. So I made a mistake. There was a minus when there's a plus. Took me forever to find. Anyway, the acceleration is 4.80758, assuming it's AX this direction. Now, with that said, we could go down to, I mean, this equation technically, but it's actually this equation. So we could do V final square equal V initial square plus 2A0 S minus SO. With that said, let's go with the initials. The initial was 9.38 square. The final was 0. And it's minus 4 parentheses 4.80758. And then it is trying to, this is 0. So it's S. So S equal negative 9.838 squared divided by 4.80758. So if I plug that into my equation over here, I get what? Let's see. Division. It's gonna be 9.38 squared. If I remember, if it was actually that. I should check if that was on the last question. But 4. Do you want to, negative cancels out, so just put plus there for now. And then 4 point. Wait, did I do something wrong? Yes, I did. It doesn't even make sense. It's supposed to be 2. 2. I was about to say that doesn't make sense. If I remember correctly. 80758. Enter. Ooh, about 10. Um, that feels right. But what was it? Ah, it was 8-3. Sorry. It was going the 9 direction. I was like, no, none of the answers make sense. So I flipped it 8 and 3. So yeah, I get 10.0496. Okay, so it's D. Okay, that we move on. Let's turn off the camera for this to save the lagginess. Still laggy if you don't turn off the camera. Anyway, in standard gravity, block A exerts a force of 10,000, and block B exerts a force of 7,500. Block, both blocks are initially held stationary. There is no friction, and the pulley has no mass. Okay, so clearly, this one has tension B, this one has tension A, this has tension B because it transfers. Tension B, no A, tension A, tension A. Now the problem is, it's no longer stationary. So what's happening here is that we cannot just assume things anymore. We have to actually figure things out, which, because they're not zero, they are moving. So find the solution on block A will require me to do this. Summation Fy equal Lay. All right, 10,000 minus plus T equal MAA, and that's a MA, I mean, that's already equation. So MAB A 7,500 plus TB A. Okay, we got it. Now here's the thing, they're all in tension. So there must be a relationship between AA and AB. And that relationship can be found by saying this. And this is the weight of the block, right? Does it say weight? In standard gravity, yes, so it's the weight of the block. So we can combine the TA equal T. Okay, so obviously we know that the TA must equal TB, right? I mean, there's no question about that. But one thing you also need to know is that A must equal minus AB. So we can actually erase this and do minus A. Because the acceleration, if this goes up, no, this could go on, then this go down. But if this goes down, this must go up. Then the relation to acceleration is the same thing because it's connected to each other in perfect unison. It's not have any friction loss or any of those taunt problems. So basically, this is true in ideal cases. We have two unknowns, two equations. Now it's solvable. You might be asking, hey, we don't know mass of A and B. Well, MA is equal to 10,000 divided by 9.8 because mg. Mass of B is equal to 7,500 divided by 9.8. So there we go. We have everything. So AA equal M. I mean, we're not looking for tension, right? We're looking for that. So we actually should give this in T equal MAAA plus 10,000, which means minus MB. So we can just do AA divided by equal mb negative 70,000 plus ma plus 10,000. So ma equal negative 750 parentheses whatever ma is, which is 10,000 divided by 9.8 multiplied by aa, which, wait, no, I fucked up. Sorry. I was supposed to isolate one of them, but I didn't isolate properly, so yeah. Let me isolate properly here now. So this equals mb ma minus t equal negative 75,000. So we could say negative mbaa minus maa minus 10,000. So we can say minus mb minus ma parentheses aa equal negative 75,000. So equal negative 75,000. 100. Why do I keep on saying 1,000 is 100? I kept on doing that. All right. You're making that dumb mistake. Okay, there we go. Yeah, that should be it. You can divide both sides and b plus whatever the mass is. So let me just grab my calculator and wherever my calculator is. Division 7500 is actually minus for minus 7500 plus 10,000 negative m, which is division of whatever this is, which is just, oh wait. This is supposed to be minus. I don't know why I put plus there. All right. MB 7500 9.8 minus, what is it? Division 10,000. I guess another thing to note is that while you're plugging in, you can literally double check in your head. Like you can figure out what you're doing. I got MA negative 1.4, and that makes sense. Negative direction going down way, so it's 1.4. I'm assuming it's asking for a different coordinate system usually. So B. Anyways, with that said, find the velocity at block 2.6 after the block is released, assuming that the acceleration is constant, which is 1.4 meters per second downwards. Uh, so what is the velocity? V final equal V initial, which is 0, minus, for it's usually plus, right? No, so it's plus, but because of the minus, it is 1.4 d, right? And then I just plug that in here. So it's basically 1.4 multiplied by 2.5 seconds, which is 3.5, which is B. We have answer. Yeah. Good. What is the period of a pendulum that passes the center point 20 times a minute? So what's think about it for a second. 20 times, right? We're going for seconds, right? There's 60 seconds in a minute. So if we're thinking about 20 times the revolution, right? We can just divide these two. And how we'll do it is there's 20 minutes, right? Not 1 minute, right? You divide by 20, it's 3 seconds. In my opinion, that is right. So how I knew that was, think about it. If I divided by 60 over 20, this is seconds over rev, that equals a second. If I were to do 20 over seconds, I'll get rad. I get 1 over s, which is rad, which is not correct. That's how I figured it out, without basically more Buckman pi ideas. Okay, a variable force of 40 cosine theta. I'm assuming the variable force is because the theta can change or something. I hope. To the end of a spring constant. Oh, maybe not. Okay. There's a K spring that is 50 and attached to some kind of angled force, I guess. Um, there is no deflection when 90 degrees. So when angle equals 90, that is basically equal to 0, right? Cosine of 90 is 0. Now, what angle would the spring deflection 20 centimeters from its equilibrium position? Okay, this is what it's saying. I guess we're not caring about if we had a real spring, it would curve, but in this case, we're not going to actually care about that. So deflection, right? So deflection, okay. So we need to care about F equal KX, first of all. That's what Hooke's law is. And if we have a force like this, 4e cosine theta equal kx, and the deflection we want is cosine theta equal, where is the 50, and then multiplied by 20, so 0.2. Okay. Cosine theta equal 50 multiplied by 0.2 divided by 4e. So cosine inverse multiplied by 50 multiplied by 0.2 divided by 4e. Yeah, that's a good answer. Divided by 50 multiplied by 0.2 divided by 4e is 75. So I think it's just this. That is a weird question. I must admit I don't like it because it's so weirdly just plug it, but not plug it, but it's weirdly just doing that. I I didn't show much of. I mean, both of these questions feels like something's missing. I don't know, but whatever. Not my time to judge. A spring has a constant of 50. And the spring is hung vertically, 50 newtons per meters. Okay, and a mass is attached to end. The spring end is displaced 30 centimeters, so 0.3 from its equilibrium position. Okay, so it's about here. Okay, the same mass is removed from the first spring. There's two springs. Okay. Okay, interesting. Attached to the end of a second different spring, the displacement is 25. What is the spring constant of the displacement of 25? What is the spring constant of the second spring? Oh, okay, yeah, that makes sense. Yeah, that checks out. Okay. So there's two springs here, and over here is k equal question mark, and over here is m, and the same m we get, and then this one gets 0.25 instead. So what that means, first of all, ma over here, first of all, I need to like first visualize this a little bit. So in this case, the sum of force in the x direction, or the y direction, which equals kx on the top, so it's going to be a kx over here. Actually, am I supposed to use this like, no, no, I don't think so. I think F equal K1 X1 is here, K2 X2. But here's the thing. This should be in the equilibrium section. This is statics. Really weird in this dynamic section. But think about it for a second. The mass doesn't change. Mg doesn't change. It has to have this form over here. So this over here has F spring, F gravity. They must be balanced. F spring must equal Fg. Over here, it must balance. F spring must equal Fg. What that means is Fg is the same. So spring 2, 1. F spring 1 must equal F spring 2. And this is a summation of MAY equals 0, basically, in this over here. So K1x must equal K2x. So K2 must equal K1x1 divided by x2. And that must mean K2 equals 50. So clear, multiply 50 multiplied by 0.3 divided by 0.25, which equals about 60. So K equals 60 is what you should get. Okay, let's go to the next question. A cannonball with a mass of 50 kilogram is fired from a cannon of mass 250. Oh, this is a moment question. MV equal initial equal summation MV final I, so initial final basically. I can already tell. The initial velocity of the cannon is 100 kilometers per hour, 1,000, sorry. All the cannon recoil is absorbed by the spring with a spring constant of what is the maximum recoil distance of the cannon? Really now. Um, Honestly, this requires energy. This is conundrum. Because you require energy, and this section is not supposed to have energy right now. So I don't know why it's doing it here, but we'll do it. Um, yeah. Uh, let's do it. So MV is 0 in the beginning, so it is 0 equal MV, and it's just that. Cannon, and then ball, right? So yeah, surprisingly, that would mean that MB ball, which is already given the ball, right, is 1,000. So let's get the 1,000 out, kilometers per hour, and multiply it by 1,000 and 3,600. All right, get your calculator out and do that real quick. Division 1,000 divided by 3600, multiplied by 1000 again, is about 277. So this is like the mass of the ball. Mass of the ball, what's the mass of the ball? And there's no angle to this. Mass of the ball is 10 kilogram, multiplied by 277, which divided by m equal negative v c. So you have to do v canon equal this. So this v canon equal negative 10 over 277 divided by 250. 277, 250. Oh, my apologies for not, you can't see that, can you? So it's negative v canon equal negative 11.08 meters per second. You could, in theory, have not done it that way, but next you need to turn all of is absorbed completely. So kinetic energy 1/2 mv squared must equal to the 1/2 kx squared. And k is, okay. So get rid of those. So mv squared divided by k square root equal x. So this is just doing energy. So what's the mass of the cannon? 250 multiplied by 11, so parentheses this, square, divided by 520 equal about the 7.6. Oh, am I made a mistake here? Did I make a mistake somewhere? I probably did somewhere. I just don't realize it. I think somewhere I missed like something. I don't know. I got 7.67, which tells me something. Let me check something real quick. 10, clear, 10. So 250, right? And that is 10. Uh, yeah, that sounds right for me. The okay. All right. I think I just made some kind of mistake. I don't know. 1000 multiplied by 3600. There. Yeah, I got that. Negative 11. And then negative 11 goes into here. Squared mc is the mass. Where's the mass? Mass is 250. Shutter cannon. 250, right? 250, 1/2. 1/2 gets deleted. Um, yeah, that sounds about right. What did I do? Oh, look here. 520 newtons per cm. So I have to multiply this by something. So careful on the units. Always check your units. Clearly I made a mistake there. So 520 newtons per cm. We know 1 cm equals 100. No, it is, yeah, it is 100 division. So meters, right? So with that said, let's go back to the equation over here that I was doing. Yeah. So no, I think I did this wrong. It is 1 centimeters, 0.01, sorry. And that's the meters about. Or 1000 centimeters equals 100 centimeters equal 1 meter. That's correct. That sounds wrong. All right, I get 0.7682, which is C, and we move on. Make sure to check your units. So they might not be the right units. A child keeps a 1 kilogram airplane flying horizontally in a circle holding along with attached string that is 1.5 meters. Yep, 1.5 meters. With that said, um, the string is always in the plane of a circular path if the fly is doing 10 meters per second. What's the tension on the ring? I believe this is going AC equal R omega squared. But if you don't remember, go down over here. This should be this thing. Yeah. In that sense, or you can use this one. This one's more clear. That's AC is that. It's minus, but AC doesn't really matter. Now, what is the tension over here? We have velocity, so omega R equal V. So with omega R equal V, which means V over R square square. So AC equal RV square R square, which is equivalent to say V square over R. So 10 square divided by 1.5. I guess also make sure about the dimensions. I don't know why they don't stick with one dimension. They really should. Okay, I get this. I get 66.66 bar, which is D. I don't like it that they change dimensions sometimes, which is weird. Well, that's your opinion. That's my opinion. But I guess the real world works like that too, actually. A car with a mass of 530 kilograms tows a trailer with a 200 moment. What's the total momentum of the car trailer combined? So a car of mass of 50 tows a trailer with a mass of 200. Okay. Wait, isn't that just MV? Um, I don't see any reason not to just do MV here. What? Okay. So 1530 plus 200 is 1730, and 1000 kilometers per hour is just times by 1000 divided by 3600. So MV equal P, which means 1730 multiplied by that give you the answer. The velocity is 100 multiplied by whatever this is, which is 1000 by 3600, 100, sorry. So 1730 multiply that equals what? That's totally wrong. What happened here? Let me double check my math on that. So 127, okay, and then it's 1530 plus 200. Okay, that multiplied by the original number is about 46710. Oh, I need to round up. No, duh. I got the right answer earlier too. I just didn't think of rounding up. Yeah. Probably because the rounding up issue is because probably I didn't do exact. I did 20 multiplied by 27 instead of 27.778, which could have caused a problem. Oh well. A car pulled a trailer at 100 meters per second. A 5 kilogram cat riding on top of the roof of the car jumped from the car to the trailer. What is the change of momentum? So is this part of question 12? 12 and 13 is connected or something? No, I don't think so, but no, that's interesting. That's good. Anyway, a car is pulling a trailer like this. And wait a second. This is B. Um, it's the same item. What kind of question is this? It's just B. Because you're jumping internally. Externally, it's MV still. It's nothing changed. So I don't understand what the point of that question was, but that's true. All right, 3,500 kilogram, 3500. The constant forward tractive force is 1,000 newtons, and the constant drag force is F drag is 150. What's the distance will the car travel in 3 seconds? Okay, so okay, the constant forward attractive force is 1,000, and the constant drag force is 150. So 100 minus 150 equal max. It's a summation of fx equal this. I'm assuming there's no other force, so that is 1,000 minus 150, which is 850 equal max. Max equal 850 divided by the mass, which is 3500, which is interesting. 850 3500 equals something about 0.24 about. Okay. With that said, that's constant. So what's the distance to travel in 3 seconds? Well, V final equal V initial plus A. Wait, we don't need to do that. We can just do S final equals 0 plus 0 minus 1 half A plus 1 half T squared. So 1 divided by 2 multiplied by 0.24 multiplied by whatever T is, which is 3 squared, is 1.208, which is about 2.21, 1.1, sorry, and that's B. Okay, I think, yeah, that's angular things. So we're done with the kinetic section.